tingle you feel when touching the protein drink bottle is most likely due to static electricity. This phenomenon is common with plastic materials, especially when they are shaken or rubbed, creating friction. Static electricity is an imbalance of electric charges within or on the surface of a material. This imbalance results in an electric field that can be felt as a shock when discharged. In the case of the plastic bottle, shaking it vigorously causes electrons to move around, creating a charge imbalance between the bottle and your body. When you touch the bottle neck, which is conductive to a small degree, this accumulated static charge discharges through you, resulting in the tingle or mild shock that you experience. There are several factors contributing to this. Firstly, the type of plastic used in the bottle and label plays a crucial role. Certain plastics are more prone to accumulating static charges than others. Secondly, the humidity in the environment can affect static buildup. Drier air promotes static electricity, while higher humidity allows charges to dissipate more easily. Thirdly, the friction generated by shaking the bottle is directly related to the amount of static charge produced. More vigorous shaking leads to a greater charge buildup. Fourthly, the conductivity of your skin and the surrounding environment influences how strongly you feel the static shock. If you are well grounded or your skin is dry, you are more likely to feel a stronger shock. It's important to understand that this static shock is not dangerous. The amount of charge involved is very small and the discharge is brief. It poses no health risk and does not require any special safety measures or changes to building codes. The voltage may be high, but the current is extremely low, making it harmless. The reason it does not require any changes to building codes is because building codes address electrical safety hazards related to the building's electrical system, such as wiring, grounding, and bonding to prevent electrical shocks from faulty wiring or equipment. These codes are designed to protect occupants from potentially lethal electrical currents. Static electricity, on the other hand, is a surface phenomenon that does not involve the building's electrical system and poses no significant risk. If you're concerned about the static shock, there are several simple steps you can take to minimize or eliminate it. 1. Reduce the amount of shaking you do to the bottle. Shake it gently, or not at all if possible, to minimize the buildup of static charge. 2. Try using a different type of container. Glass or metal containers are less prone to static buildup compared to plastic. 3. Increase the humidity in your environment. Using a humidifier can help dissipate static charges more effectively. 4. Ground yourself before touching the bottle. Touching a grounded metal object, such as a metal faucet or appliance, can discharge any static electricity that may have built up on your body. 5. Wipe the bottle with an anti-static cloth or spray. These products can help neutralize static charges on the surface of the plastic. 6. Consider the clothing you are wearing. Certain fabrics, such as wool or synthetic materials, are more prone to generating static electricity. Wearing cotton clothing can help reduce static buildup. 7. Store the bottles in a different location. If the bottles are stored in a dry environment, moving them to a more humid location may help reduce static. 8. Apply a thin layer of anti-static lotion to your hands. This can help prevent static charges from building up on your skin. 9. Avoid rubbing the bottle against other materials. Friction is a major cause of static buildup, so avoid rubbing the bottle against your clothing or other surfaces. 10. Discharge the static electricity before opening the bottle. Briefly touching a grounded metal object with the bottle neck before opening it can discharge any static that may have built up. Static electricity is a common and harmless phenomenon that can occur with plastic bottles. It is not a safety hazard and does not require any changes to built-in codes. By taking simple steps to minimize static buildup, you can easily avoid the tingle or mild shock that you may experience. Instead of changes to building codes, focus should be placed on understanding the properties of the material to find the root cause of the static buildup. Static electricity is governed by the triboelectric effect. When two materials come into contact and then separate, a transfer of electrons can occur, leading to one material becoming positively charged and the other negatively charged. The position of a material in the triboelectric series determines its tendency to gain or lose electrons. Materials higher in the series tend to lose electrons and become positively charged, while materials lower in the series tend to gain electrons and become negatively charged. The magnitude of the charge transfer depends on several factors, including the materials involved, the surface area in contact, the pressure applied, and the speed of separation. Surface conditions also play a role, as clean, smooth surfaces tend to generate less static than rough or contaminated surfaces. Humidity affects the triboelectric effect because moisture in the air can provide a conductive path for charge dissipation, reducing the buildup of static charge. In dry environments, the lack of moisture allows charges to accumulate more easily. Temperature can also influence the triboelectric effect, with some materials exhibiting different charging behavior at different temperatures. The material composition is critical because different materials have different affinities for electrons. Choice of materials for the bottle and label significantly impact static charge generation. For example, using materials that are close together in the triboelectric series can minimize charge transfer. Surface treatments can also be applied to modify the surface properties of the materials and reduce static buildup. Anti-static coatings can provide a conductive layer that allows charges to dissipate more readily. The design and shape of the bottle can also affect static charge generation. Sharp edges and corners can concentrate electric fields, leading to increased static discharge. Smooth, rounded designs can help minimize this effect. The thickness of the plastic also matters, as thicker plastic may accumulate more charge due to the larger volume of material. The manufacturing process used to create the bottle and label can also influence static charge generation. For example, the use of certain additives or processing aids can affect the surface properties of the materials. The speed and pressure used during manufacturing can also impact static buildup. Environmental factors, such as temperature and humidity, during manufacturing and storage can also play a role. The type of liquid inside the bottle could also have an impact, although generally static buildup is a surface phenomenon. However, certain liquids may increase the dielectric constant or influence charge distribution on the plastic surface. Also, the packaging design can be altered to minimize static. For example, incorporating a conductive strip or grid on the bottle's surface can help dissipate static charges. Using a static dissipative material for the label or a portion of the bottle can also be effective. The shape and size of the label can also be optimized to minimize static buildup. Smaller labels or labels with rounded corners may generate less static. Consumer handling can also influence static charge generation. The way consumers handle the bottle, including how they shake it, carry it, and open it, can affect static buildup. Educating consumers about how to minimize static charge generation can be helpful. This could involve providing instructions on the label or in product literature. Quality control during manufacturing can help ensure that the materials and processes used are optimized to minimize static buildup. This could involve testing the static charge generation of the bottles and labels and implementing corrective actions if necessary. The use of alternative materials, such as glass or metal, can eliminate static charge generation altogether. While these materials may have other drawbacks, such as increased weight or cost, they can be a viable option in certain situations. Conductive polymers can also be incorporated into the plastic material to increase its conductivity and reduce static buildup. These polymers can be added during the manufacturing process to create a static dissipative plastic. Understanding the underlying principles of static electricity and the factors that influence it can lead to the development of more effective solutions for minimizing static buildup in plastic bottles. This can involve a combination of material selection, design optimization, manufacturing process control, and consumer education. Research and development efforts can focus on identifying new materials and technologies that can further reduce static charge generation in plastic products. This could involve exploring novel polymers, coatings, and surface treatments. This information can then be used to refine the manufacturing processes and quality control procedures to ensure that the bottles meet the desired static charge performance. It's also important to understand the limitations of different mitigation strategies and to select the most appropriate approach based on the specific application and requirements. Some solutions may be more effective in certain environments or with certain types of materials. Consumer feedback can also be valuable in identifying potential issues and improving the design and performance of the bottles. Gathering data on consumer experiences with Static Shock can help manufacturers understand the real-world impact of static buildup and to develop more effective solutions. Long-term testing can also be conducted to evaluate the durability and effectiveness of different mitigation strategies over time. This can help ensure that the chosen solutions continue to perform as intended throughout the product's life cycle. Consider the grounding and shielding options for the bottles. Incorporating a grounding mechanism into the bottle design can help dissipate static charges more effectively. This could involve adding a conductive strip that is connected to a grounding point. Shielding the bottle with a conductive material can also help prevent static buildup. This could involve wrapping the bottle in a layer of foil or other conductive material. Consider the impact of cleaning and sanitizing the bottles on static charge generation. Certain cleaning agents or sanitizing methods may increase static buildup. Selecting cleaning agents and sanitizing methods that minimize static charge generation can be important. Also consider the potential for electrostatic discharge to damage sensitive electronic equipment. If the bottles are used in environments where sensitive electronic equipment is present, it may be necessary to take additional precautions to prevent electrostatic discharge. This could involve using static dissipative mats or grounding straps. Consider the regulatory requirements related to static electricity in certain industries or applications. Some industries may have specific regulations regarding static electricity and electrostatic discharge. Ensuring compliance with these regulations is important.